The old dude trying to stream. Okay, let's close this project and go to test custom type. So this is a project I started to test out registering custom types in Postgres to kind of understand better how that happens. So one of the things I'm curious about right now is what happens when I get a null back. So what does a null look like here? So let's see what we've got. Let's pop open our database. And foo has two columns, ID and a res. So yeah, this is not null. This is not null. So let's go ahead and stick see what's in foo at this point. Okay, there's one, so let me do this. Insert to foo. So when I run this, then I run this. Okay, great. So I got my null. Okay, so I got my null. What happens if I run this, just as is? So what if I make this a pointer to resolution? Awesome. Okay. So that's perfectly cromulent. I can live with that. Hmm. Okay. So just to go over the process of using PGX to register a custom data type. So we create our data type. We create a corresponding type in Go, right? So this mirrors the type we have over here, which has a width, height, the scan. The scan is a char, and the scan over here is a room because Go supports multi-byte characters, so we can't be guaranteed that something will be an ASCII single byte character, right? It could be the Swiss flag, which is a multi. I think it's it's not even a multi-byte character. It's like a multi-byte character with additional stuff on the end. So that's why we have rune. We connect into the database. I always use the same pattern of picking up a URI from the environment and connecting through that. The one difference from a normal kind of connection is we do have to, on the connection, so this, I'm using a pool, so pool supports this after connect handler. which is run after each connection is created into the pool. And it's run for each connection. And as far as I understand it, these the registering the types is done on a per connection level. So I create a new composite type, and this name matches the name in the database, and these fields match. I don't see anything that explicitly matches the type to this type. It's like, what if we changed this? We said width, let's put scan before width and height. What happens then? Okay. So we have to agree on it, right? We have to agree that we have to agree on the order of things. Let's see. Would there be some benefit into creating like a helper class that would automatically register these things? Like I could pass it an instance and it would pick it apart and register everything. What if I change the names? Bloop. Bloop. So I think that'll still work because I think it only cares about order. Yeah, it only cares about order. So as long as things are in the right order in terms of type, it should work. Yeah, okay. So this mapping, it would be nice if I could take this part from here. G-type. Just take a look at the voids. T-U. No U ints. So all the ints here are signed. So what if I change these to be something like uint? What happens then? That still works. So it would be very happy. It would be just as happy with the uint. What if we inserted some garbage in here? Let's do this. If this is negative 10, That's a uint. Oop, forgot to execute it. Let's see, W3. Let's go back to here. Let's try it out. We have 10 is less than 0 for uint. Okay. But if it's int, it's fine, right? Yeah, if it's int, it's fine. So it'll take care of the uint, the unsigned int problem. I think pretty gracefully, actually, all things considered. Let's see, can I do this? Uh, 10, 10, no. Does this work? Yeah, it does work. So what happens here? Okay. Um, Well, there's no connection here, so I could, let's comment that out. Var sum struct width, width, height, and that's star int. And scan is star room. Now let's see what happens. Can't scan into int32 star. Okay. So even if they're nullable in the database, what if I make these PG type? So the PG type, yeah, it handles nil. So this is a case where the P is nil, but because I defined it this way, this handles nil correctly. Hang on, let me take a look at something. I think that may have been changed. Let me open up a terminal. Go get -u. Oh, I want at master. Cool, okay. So the reason I did that is there was a fix recently in V4. There we go. So I think there was a fix recently that yes, there was a fix recently. So this is star int yes, okay, yeah, there was a fix recently for star rune, so it wasn't handling star rune correctly during a scan. Um, but that's been fixed, so now that works. So yes, so that's how I handle nills. So um, so maybe I have a type called resolution DTO, which is a struct, and it has width, height as star int, and scan as star rune. And we use that and let's go ahead and add a string method to it so that type and what we want to do is do the same thing as this, right? Except we are yeah, because that'll give me the no, it won't give me the zero value. It'll fail, right? It'll fail. It will fail, right? We'll get a panic. No, we don't get a panic. Oh. Yes, we do get a panic. Because this doesn't point to anything when we do reference it. Okay, so that makes sense. So we don't do that. What we do is we have as solution and if dto dot width equals nil, so we just do these null checks, right? What if there's a better way to do it in Go? So height and scan. And let's say I want to make this by default P. So if I do this, yep, I have to check to see if sum not equals del. So let's take a look at that. Okay. Yeah, so that handles, let's go back to console, select start from foo. Okay, that handles a situation where, of course, I've got a completely formed custom type here. I've got null for the type, so there's no value. This was to check what happens with unsigned ints versus ints. It seems to fail in a way that it's least understandable. I could probably fix the error pretty quickly. And then what happens if a field is null? All right. So what's interesting is it's smart enough, PGX is smart enough to understand that this could be null, in which case that would be set to nil. Okay, so we could insulate ourselves from that a little bit using some kind of data transfer object to kind of handle the null cases and fix up the database object into something that we can understand. Can I no, I don't think I can make something not null a type. Okay, well that's it. That kind of explains it. We had some comments here. Except we might do handle nulls, in which case we'll go this has nullable fields, which deal with the database, possibly returning null. Convert the DTO with its nulls into a semantically valid application type. Okay, so there we go. So now we can say, go down here, you can say this is a pointer to the DTO. Because our row might be null. Because our value might be null, in which case sum would be set to nil. Let's go grab these. So we will go ahead and put these in here. Okay. Let's put this in. If you can guarantee will not be null, then you don't need the DTO and you would just have a type above. If you can fields in the resulting object will never be null, you can use a pointer to the resolution type instead of the DTO. All right, so let's push this up to GitHub. Commit and push. Updated for pullable fields example. Okay, I think that's it for today. Well, that is my first real attempt at streaming on Twitch. Let's see how it goes.